Welcome to this little video on indices. Today we're going to look at rule 1 of indices, which deals with the multiplication of terms. This is your introduction to indices, so it makes sense for us to just talk about what indices are. We will refer to this, if we're talking about just one of them, as an index, and indices is the plural of that if we're talking about multiple indices. They have other names as well. Sometimes we call them exponents or powers, so you might find I interchange between those words, but they all mean the same thing. To point out where they are, it's these little numbers up at the top of a term. This can be a number or a letter, and what we're going to do is look at what do we use them for in maths, why do we use them, and how do we process them. I'm going to start with some really basic examples, just looking at multiplication of singular terms, a couple of numerical examples, and then one with some algebra in. And indices and these rules that we're looking at is a notational thing. We're looking at how can we write repeated multiplication today as a kind of simpler format. I guess you've seen something like this using scientific notation, a way of writing really big or really small numbers more concisely. We're doing the same thing today, except with multiplication of terms. So what we're going to do, we're going to take these examples. The important thing to note when we're dealing with indices is that these rules only apply if what's called the base is the same. So the base is the number or the letter that we're multiplying together. So if this was 7 times 8 times 9, this rule wouldn't apply. Similarly, if this was A times B, the rule wouldn't apply. Okay. It's really straightforward. We're going to take 3 7s and multiply them together. And you've seen this before. We know already that 7 cubed represents 7 multiplied 3 times. But one thing that you can't see with these numbers, and it's maybe important that you recognise is there, is that there's actually little invisible indices with those. This is just 7 to the power of 1, 7 to the power of 1, and 7 to the power of 1. We don't write it if it's 1, which is why you can't see it, but it is there. Seeing it might help you understand where this 3 is coming from as well. Okay, we're going to take the second example now. We've got these 9s. How many of these 9s are multiplying? We've got 1, 2, 3, 4, 5. And so we're going to write that as 9 to the power of 5. And then similarly, down here with this last one, we've got some letters multiplying. They're the same, and that's really important. How many of those letters? We've got 1, 2 A's multiplying together. And we know this already as A squared. I'm going to flick over the board now and have a look at something slightly more complicated. So we've got a few examples here. I'll just tidy that one up, and we're going to see if we can do this if it's already written with some index notation in it. A good way to kind of think about this is 3 8s multiplying together already, and this is 4 8s. So how many 8s multiplying together do we have in total? And the little rule from the previous slide helps us with that. If we're multiplying these terms together, then we add these indices. Yeah, I'll just highlight that there. We're going to be adding these two values together. The base stays the same, so we've got the value 8. How many times have we multiplied 8? 7 times. On to the next one then, similar strategy. We've got A multiplied by A to the power of 4. And that gives me A. How many A's are multiplying? We'll add 2 in the first place, multiplied by another 4. So A multiplied by itself 6 times. On to a couple of trickier examples now. We need to kind of understand the rule that what we're doing when we multiply these things is we are adding these indices together. And so what we've got in this one that makes it a bit trickier is we've got this negative value here next to this second y. The rule's the same though. We're multiplying y's together, so it's still going to be some quantity of y's. We've got 3 of them multiplied by -2, or actually, sorry, in terms of the rule, we're adding. And so we end up with 3 plus -2, remember, is like a subtraction of that 2, gives me y to the power of 1. I mentioned earlier that we actually don't write y to the power of 1, so the answer to this one would just be y. Okay, on to the last example, and then you'll be able to try your little task for today. This one has not only indices, but it's got what we would call coefficients, numbers in front of the letter. And it's important to differentiate between when do I use the rule of indices and when do I just do what the operator, this multiplication, is telling me. This new rule that we're learning only applies to these numbers here. for these coefficients, these big numbers at the front, we do what the operator says. So 4 times by 2 is 8. Our base is the same, it's b, so we're going to have some quantity of b going on in the answer. How many of those? These are indices, so we apply a rule, which is to add these two values together. So the answer to this one is 8b to the power of 8. Hope that's been a helpful introduction. You can tie today's task now, and remember, check your answers and get in touch with your teacher if you need any help.